Hello, so today we're going to be doing this integral equation from Berkeley Math Tournament. So the question reads here, the non-zero functions u of x and v of x satisfy the integral equations integral of ux with respect to x equals x squared times u of x, and the integral of ux vx with respect to x is equal to the integral of ux with respect to x times the integral of vx with respect to x. And they want us to find the simplified expression for ux and v squared x in terms of an arbitrary constant. So I will start with ux first, and I'll be using this piece of information in the question to find it. So we have integral of u with respect to x equals ux squared. So differentiating both sides, we get u equals 2xu plus u, I'll write this in Leibniz notation, du dx x squared by the product rule. And so I'm going to bring this over and factorize out u. So u 1 minus 2x equals du dx x squared. And now it's separable, so combining everything here, we will get the differential equation 1 minus 2x over x squared dx equals du over u. So I'm going to integrate both sides. And so what we'll get for this is negative 1 over x minus 2 times the natural log of absolute x plus an arbitrary constant c is equal to the natural log of the absolute value of u. So obviously to find u, we raise e to the power of this. So we'll just do u equals e to the negative 1 over x and times e to the natural log of x to the negative 2 times e to the c. And simplifying all this, we will get u equals, and I'll rewrite e to the c as a, e to the 1 over x squared, and I will write where a equals e to the c is an arbitrary constant. Okay, we've found u. Great. So now all that's left for us to do is to find v squared x. And I will be using this piece of information. So let's write that down here. Integral of u v with respect to x equals integral of u with respect to x times the integral of v with respect to x. And again, nothing much we could do here except differentiate both sides. So u v equals v integral of u dx plus u integral of v dx, again by the product rule. So as you can see here, we actually know the result of this integral, and it's x squared. So I'm going to rewrite this term as that u v equals vu x squared plus u integral of v with respect to x. And notice that we can just divide u from the entire equation. So v equals vx squared plus integral of v with respect to x. So I'm gonna bring this term over. V minus vx squared equals integral of v with respect to x. And again, we will differentiate both sides. So v prime minus x squared v prime minus 2xv equals v. Okay. Now I'm going to do some algebraic manipulation, and we will get, if we bring this term over, and factorize the v's out, we'll get v prime 1 minus x squared equals v plus 2, sorry, I want to factorize out v, 1 plus 2x. So rewriting this using Leibniz notation, we get dv over dx 1 minus x squared equals v1 plus 2x. And this is a separable differential equation, so dv over v equals 1 plus 2x 1 minus x squared dx. And of course, we're going to integrate both sides. In order to integrate this, you will have to do partial fractions. And if you do the partial fractions, you will get 3 over 2 1 minus x minus 1 over 2 1 plus x. So I'll use that result. So the natural log of the absolute value of v is equal to the integral of 3 over 2 1 minus x minus 1 over 2 1 plus x with respect to x. Okay, and I will move up here. So do we have? Okay, so actually I'll just write down the result of this integral here. It's equal to 3 over 2 negative, because here you have to substitute u equals 1 minus x, and you will end up with dx equals negative du. So obviously this is negative. Natural log absolute 1 minus x minus 1 over 2 natural log absolute 1 plus x. And of course, we can't forget our arbitrary constant. And I will bring everything, and to make our lives easier, I'm going to multiply both sides by 2. So 2 natural log of the absolute value of v is equal to negative 3 natural log absolute 1 minus x minus natural log absolute 1 plus x plus, and another thing I'm going to do to make our lives easier, lnk, where lnk equals c. So I'm just going to use logarithm properties to rewrite everything. So natural log of v squared, note that we don't need the absolute value anymore because v squared is always positive, equals natural log of one big absolute value, big fraction, 1 minus x to the 3 to the third power, 1 plus x into 1 plus x, k, and there. And so formally writing our answer for v, we get v squared equals k over 1 minus x to the third 1 plus x. And that is our answer for v squared. And this is our answer for u. That's pretty ugly. Okay. Yeah, so we are done.